Okay, so this video will be all about our best friend, the imaginary number I. So I is equal to the square root of -1. Another way you can say it is if you take I times itself, you would get -1. So an imaginary number doesn't have to be just I. Imaginary number is also classified as things such as 6I, because it is a number times an imaginary number. So the I works like almost every other variable you encounter. If you add it, 5I plus 2I, you have 5 I's and you add 2 more I's, so you would get 7 I's. If you subtract it, it's pretty much the same thing, 5I, and then you take away 2 I's, you would get 3 I's. Now, if you multiply them, 5I times 2I, what you do is you're multiplying these two, but then you also multiply the i's together. So you take 5 times 2, which would be 10, then you have 2 i's together, which is I squared. And as we said up here, I squared, or I times I, is equal to -1. So that would be -1 times 10. If you divide them, 5I divided by 2I. Like we said in class, these will cancel out, get 5 halves. Now, if you have it with just 5I and 2, the I will stay because it is not being divided by another I below. It will be 5 halves times I. Now, let's go through some examples of i's and square roots. So, say we have the square root of 36, -36. You can do is just take the I out of that. You have I. Then the root of 36 is 6 times 6. You get 4I. Another thing we did today, just to refresh your memory on it, we did the square root of -3 plus the square root of -27. We took the i's out of it. Sorry if my eyes look a lot like J's. We had root 3 plus I root 27. We said that this could be broken down to 9 and 3. 9 is a perfect square, so we can take that out as I root 3 plus 3I root 27. Now, what I said is we basically have one of these I times, no, sorry, that is my fault, it is a 3, they're not a 27. Of 1I times root 3, and we have 3I times root 3. If you add 1 plus 3, it's 4I root 3. Now, powers of I, we never really got to that in class. But it would be something like I to the first power. It's just I once. So that would be I. Then we have I to the second power, which we said earlier was -1. But then when we get I to the third power, well, I to the third power is I to the second power times I. And I to the second power is -1. So -1 times I, you would get a -I. If we go I to the fourth, I to the fourth is I to the second times I to the second. So I to the second is -1 times I to the second, -1 again. -1 times -1 is 1. The nice thing about this is it repeats like that. If you have I to the fifth, you just said I to the fourth was 1 times a single I, which is I. We'll find, as you go through this pattern, that I to the sixth would be -1, I to the seventh would be -I, and I to the eighth would be 1. So one thing you can do to kind of just skip through this would be, you have your I to the exponent. Let's say, in this case, it is 11. You would divide it by 4, and 4 can go into 11 2 times with the remainder of 3. So we look here, okay, there's a remainder of 3. So we go 1, 2, 3, that's it. Our answer would be a -I, because it does repeat in this pattern. I, -1, -I. Let's do some more problems, just to, in case you are still confused. So, number R on the quick check, it was the root -9 plus root 49. Oh, -49, I am sorry. Now, we can take the i's out, but since 9 is already a perfect square, it's 3 times 3, you can just take that out and get 3i. Then we add that, we take the I out. We also notice that 49 is a perfect square. It is 7 times 7, so we would get 7 i's. Using this, we have 3 i's plus 7 i's, so we would get 10 i's. If you are, this is letter Q, -4 divided by 4, square root of -4. So with that, over 4, see, well, there's a negative sign. We can take out our I, but 4 is also a perfect square. It is 2 times 2. So we have 2i over 4, which is 1/2 I. Okay. Letter K, we had -4 root -36. So -4 stays out here. Then we can take an I out, times an I. Then 36 is a perfect square, so we can also take that out. We have 6. 6 times 6 is 36. So we have 4 times I times 6. 4 times 6 is 24, and since it's negative, there's only one negative, it would be -24 times the I.